what is the formula for the area of a parallelogram? We're going to use area is base times height. But before we look at some numerical examples of that, I just want to look at some pictures to show you how base and heights might look. They do go in pairs. So for instance, on the left-hand example, if I think of this bottom side as the base, the height might be drawn from this upper corner here. It does need to form a perpendicular angle with the base. So that would be one option for the height, or it could be drawn on the outside of the figure as long as it would be perpendicular to that side extended. So a height is going to be perpendicular either to the exact actual side or to the side extended. If we look at one of these sides of this next one in red being the base, our height could be drawn again outside the figure. It does need to be perpendicular, or it could be drawn inside the figure. Now do keep in mind that since it is a parallelogram, if that left-hand side is a length b, then that means the right-hand side would be that same length, because if you recall, opposite sides of a parallelogram are congruent. So they might even have both of them in a picture. Again, if I color code this, let's say the top and bottom sides are a blue length, the height could be in these two places most likely. And then if I think of the red sides as the base, then the heights might be drawn in these two locations, most likely. The important thing is to find that perpendicular symbol, because remember, you can't assume that it's perpendicular, even if it might look like it. You need to know for sure. On to the examples. So here we have a parallelogram. Now the area is base times height. I see right there is my perpendicular. So the base is 10 and the height is 6, giving me an area of 60 units squared. And the next example, another parallelogram. They've thrown in another number. No problem. Here, though, we find the perpendicular symbol. So that means that 4 is going to be my height. Now I just need to decide, does that 4 run into the 5 at the perpendicular angle, or does it run into the 7 at the perpendicular angle? Since it would run into this extension of the 7, that is the base. So the base is 7, the height is 4, so it's 28. And again, it's units squared because it is an area. And it wasn't specified to me whether they were in inches or centimeters or what units were being used. Now, this picture might make some people uncomfortable because that height is not pointing down to the bottom or pointing down to the ground. Even though we can still see that perpendicular up there, some of you might prefer to tilt your head or redraw the picture so it looks more like this, which is perfectly acceptable. So here we go, area, base times height. Again, there's that perpendicular that I saw earlier. And the numbers are on their sides now, so you might have to tilt your head again. And the base is going to be 12, and the height is 8, giving me an area of 96 units squared. And that was where that might be asked to find something a little bit different. Here, there's an unknown height that I'm trying to find, but I have a lot of other numbers on this picture. So what I can do is use a pair of base height numbers or values that I know to find the area of the parallelogram. I see here's a perpendicular with a number for a height and a number for the base. So I'm going to use those two values, 20 and 12, to find the area of this parallelogram, which I see is 240 units squared. Now this parallelogram is not changing its shape or its size, shrinking or growing. It's just sitting there like a good little parallelogram does. And so its area is not changing. So that yellow area is still the same. All I'm going to do is now use my other base height pair to find the height. Plugging in to this formula the things that I already know. Well, I already know the area is 240 this time. And now I'm going to look at that 15 as my base value and the h is my height. I now have an equation with one variable, and I just solve it, in this case by dividing by 15 on both sides. And I find out that the height at the top there would have to be 16 units. It is no longer squared because height is not squared. Let's try one more example of this type. Starting off the same way that we did before. Area is base times height. Look on this picture for a pair of base height values that you know. Okay, hopefully you've found that you've got an 8 for height and a 14 for a base. So plugging those numbers into the formula, we end up with an area of 112 units squared. And now, using my other values, I know the area is 112. Again, it didn't change. The base that goes with the h for the height is 10. And then I just have the h for the height. Divide both sides by 10. And I find out that the height of that part is 11.2 units.